We're going to take a look at the new simulation feature, which is part of Automic Automation Intelligence. And this is a feature which will allow you to simulate changes that you plan on making to your production jobs prior to moving them into production. It's particularly useful to see if any of the changes that you're planning will affect any SLAs that you have in place. So as an example, let's take a look at this market pricing application, which is currently running in production. This is an AutoSys job stream, and there's an SLA on this market price 003 job. And in fact, this market pricing application is an intraday application. It runs every 30 minutes. And you can see in this drop-down that there's a run for it all during the day at every 30-minute interval. And typically it starts on the half hour and the hour, and it runs for about 35 minutes or so. And you can see here that this is the SLA. This red dashed line over on the right is the SLA. So on average, it does not currently breach its SLA. Within this job stream, there are a couple of boxes. So this market price New York box is an AutoSys box that within it has another box called Market Price Chicago, which has a few jobs inside of it. So the plan is the proposed changes to production are to add another box within Market Price New York to do additional processing, which will run at the same time as the Market Price Chicago box, and will be required for the Market Price Los Angeles to complete in order for this successor job to run as well. So what we want to do is simulate those proposed changes without actually making the changes in the scheduler and see if the changes that we're proposing would have any effect on the SLA. So to do that, we can go over to the web user interface, which I will bring up now. And we want to navigate from the context menu to the simulation context, which is what we're currently looking at. And let's say we want to run a new simulation. So when we run a new simulation, the first thing we want to do is select what time we want to simulate. So I'm going to, for purposes of this demonstration, select tomorrow. So today is April 6th. I'm going to select April 7th. At around the same time of day. Now remember, this job stream is running every 30 minutes, so we're going to start it tomorrow at about the same time of day. Then you have an edit field here where you can type in the GIL that you are planning to, the job definitions that you're planning on simulating, or what would be easier would be to load those in from a file. So I'm going to choose to append these GIL contents from a file. And I happen to have my GIL file right here in my file browser. I'll bring it in, and you'll see the actual GIL. This is the GIL that's being proposed to be moved into production. And it's relatively simple. There's a new box that's being proposed to add called Market Price Los Angeles, Market Price LA. And within that brand new box, there's a job called Market Price LA 001. This is all of the GIL exactly as it's proposed to go into production, with one exception, which is that for any new job that's being proposed, you can annotate the job in a comment form with an average duration. And in this case, it's anticipated that this Market Price LA job will run for 15 minutes. So in order for us to simulate what these changes, how these changes are going to affect any existing SLAs, it's important to know how long these jobs are anticipated to run for. So that is up to the user to input the average duration. It's also possible to use this average duration annotation on an existing job if the proposed changes are maybe not changing the structure, but for some reason you'll anticipate that an existing job will run shorter or longer than it currently does. You can modify this average duration even for an existing job and see how that will affect the simulation. So now we've got a new box that we're adding. the box has the same starting conditions as that market price Chicago box that we were looking at earlier. And we also modified the successor to that market price Chicago box. We updated that job with an update job statement, and we changed its condition to also depend upon the success of this new market price Los Angeles box that we're creating. And this JIL file can have other unrelated JIL changes in it as well. So the ones that we care about are the ones we just reviewed. So at this point, I'll click Next on the wizard. And now I have an option to override any of the global states that exist within the scheduler. So we're going to be simulating from the current state of the production jobs into the future. And so if there's any jobs that are currently in a failure state, we may want to add a rule to say anything that's currently in a failure state, let's assume for purposes of this simulation that that job is in a successful state. If you want to override this for an individual, this global rule for an individual job, you can add exceptions at the job level by clicking this button here. I'm not going to do that for this simulation. I'm just going to click on Finish. And when I click on Finish, it submits that simulation. One thing to note is that prior to submitting the simulation, it actually does validate the JIL. So if there were any syntax errors in the JIL that was input, or if perhaps there was a condition on a job that doesn't exist in production in that simulated JIL, you would get an error message here. But all of the JIL that we were looking at was clean, so it's processing that and it's running the simulation. Now, please remember that this simulation is just a simulation. No jobs were added to the underlying AutoSys scheduler. We're just doing a simulation here. And it took, you'll see it took 31 seconds for that simulation to complete. So it actually completed successfully. So now we can go back to our thick client and take a look at what the effect of that simulation was. So to do that, I'm going to go over to the monitoring tab. And I currently have a tab where I'm filtering, where I'm looking at my market pricing job streams. And you'll notice that within here, actually, that market pricing stream is currently running in production because, like I said, it runs every 30 minutes. And you can see here that it's running. This is just the current production run. And this job, market price New York 004 is currently running, and we're on target to complete before our SLA for this currently running in progress run. There's also a forecasted run, which is the next forecasted run, which is going to start in just a minute or so. And that one is also forecasted to be early. So now if I go in and edit this tab and I choose to include my simulated job stream runs, and I'll choose to only show the next simulated run here, what you'll see is that a new third entry appears here, which is market pricing with the purple icon and a double bar in this field. This is a simulation run. And now you can see that the simulated run with the changes that we're proposing is simulated to be 16% late. It's simulated to miss its SLA. So let's take a look at this simulated run. And we can take a look at it in comparison to this forecasted run. So I'll put them side by side so we can do a quick comparison here. The forecasted run is based upon the job definitions as they currently are in production, and the simulated run is including the proposed changes that we're simulating. So you'll notice if I open up Market Price New York in both views, that the one on the right includes this Market Price LA box, which does not exist on the left. This is the new box that we added into the middle of this job stream that we are simulating. And when you open up the box, you can see here's the job that's being simulated to run for 15 minutes. So when I take a look at this job, the details, you'll see in the Runs tab that it has, it's predicted to start at 2:50 and end at 3:05, which is 15 minutes later. So that was based upon the average duration that was fed into the simulation. So this market price LA box is running in parallel with the market price Chicago box, but the market price Chicago box only runs for about 8 minutes. So what you're seeing here is that by inserting this box into the middle of the stream and running it in parallel with market price Chicago, we're actually increasing the duration of the job stream by this 7-minute delta. And that's enough. That 7 minutes is enough to push this over its SLA. So we're now telling you that if you make those proposed changes, you are going to miss your SLA by the amount of time that you see right here. It's predicted to end at 3:13, and the SLA is at 3:07. So it's about a 6-minute breach of your SLA with the changes that you've proposed. So this, simulation gives you the opportunity to see what the effect is, because it's not really necessarily that obvious. You're adding a job in the middle that's going to run for 15 minutes, yet it didn't have a 15-minute impact on the SLA. It only had a 7-minute impact, because there's other things to consider, things that are running in parallel with it, etc. So this is just giving you an example of how the simulation works and how you can validate changes against your SLAs prior to moving them into production.